Thank you for joining us for The Sky Above, where we'll tell you everything happening in the sky this upcoming month so you can plan ahead and know when to look up. Here's what's heading your way right now on this July episode. We'll discuss the meteor shower that will show off in July and when you have the best chance of catching a glimpse. Plus, 1 year ago, a first-of-its-kind telescope went online. We'll go through some of the biggest discoveries made so far by the Reuben Observatory and how it's redefining what we know about outer space. Thank you so much for joining us. I am meteorologist Leah Pizzetti, here with you once again every month. I'm joined, as always, by NASA Solar System Ambassador, member of the Seattle Astronomical Society, Keith Crum. Keith, thank you for being here.
Oh, thanks again. Always glad to be here. Thanks.
Summer is here.
Yeah.
And we will start where we always start, with our full moon.
The full buck moon on July 29th at exactly 7:35 a.m.
Okay. So that's the full moon.
Yeah.
We also have our new moon, which we love because that's when the sky is darkest.
Yep. On the 14th of July, early morning, it'll be the new moon. Yep.
Okay, so similar to June, we will want to do our stargazing mid-month.
Yeah, it seems like some of these astronomical events are happening right around the full moon. So. Yeah, look on either side of that full moon at the same things, and you might have better luck.
Okay, all right. And another interesting calendar date, July 6th.
Yeah, the Earth is at aphelion on July 6th. That means it's the furthest away from Earth that it gets in its elliptical orbit, in our elliptical orbit around the sun, that is. And sometimes people believe, and I hear often that affects our weather, makes it it would make it cooler perhaps in the summer. It doesn't. It doesn't do that. So, it is elliptical, but it's 93 million miles away, and that only changes by 2 or 3 million miles from season to season. So, it's not going to really affect our temperature here on Earth, and that distance is 1 astronomical unit. So that's an important distance to remember.
1 astronomical unit is?
The distance between the Earth and the sun.
Oh.
Is 1 astronomical unit. It's often used, like if you're talking about, well, how far away is Jupiter? 5 astronomical units.
How can we equate that?
Yeah.
Million miles, you said? Couple million?
Yeah, well, it's 93 million miles.
More than a
average. In that average.
Interesting.
So 1 astronomical unit is that distance. So you can more easily talk about the distance to things like the distance to Jupiter by saying it's, 5 astronomical units.
Okay. So the distance to sun, like you said, it's not impacting our temperature necessarily.
Right. Yeah.
It's not really impacting our seasons. That's more so the tilt.
Right.
So why do we pay attention to the distance?
It is our solar system, and we need to know these things, where it is and how far away it is and how it moves and is it changing? Mm-hmm. It's been doing this for billions of years, and we hope it keeps doing it for a few more billion. So, we just need to keep an eye on everything and know what's going on.
Okay, so more so just for being relative to the rest of everything else out there. Okay, awesome. Let's talk about our upcoming meteor shower for the month of July. This one actually goes into August as well. Let's first talk about the timing of this one. So this is kind of end of July it starts.
Yep, the 28th, Delta Aquariids, and it's... the full moon will hinder it that night. So again, looking past it or before it is going to make it a little easier.
Okay. Is it better to do it a little bit on the earlier side or the later side on either side of that peak, July 29th, 30th? Does it make a difference?
No, I just watch where the moon is, and what time the moon comes up and down. And,
okay.
Yeah.
Okay, so we're trying to avoid that full moon at the end of July, everybody.
Yeah.
Avoid the full moon and you have a better chance of seeing those meteors. Okay, let's see. Let's talk about the constellation Aquarius.
Okay, yeah.
No.
Andromeda.
Andromeda. Let's talk about Andromeda.
Andromeda, yes. So Andromeda is up, and you can see it with your naked eye. Actually, you can see another galaxy with your naked eye.
Okay.
So, or binoculars.
Okay.
We call them faint fuzzies, small telescopes. Yeah, so it's out there look for the Andromeda galaxy.
Okay, and is there a best time to view that?
Any time after dark, really, in the summer. It's a good summer time for Andromeda.
Amazing.
And other galaxies.
Okay, great. And then, of course, we like to go through what planets will be visible and bright this month. Early July, Saturn, right? July 7th to 8th. Saturn's close to the moon.
Yes.
It's a cool sight.
Yes. Saturn close to the moon, that'll be early morning.
Okay.
Yep. And Venus is getting higher in the night sky. Again, looking to the west, it'll be higher and higher each evening.
Okay, and that mid-July, July 16th, 17th, that's when we'll have the least impact from the moon, so that could be a good time to check out Venus.
Yep.
Okay.
Yep.
And then end of the month.
End of the month, Mars becomes more visible early morning and so forth. So yeah, look for Mars. So we're getting more into planet season as the summer goes on.
Amazing. Okay. Yeah. And then, of course, Andromeda. That'll be a great thing to see. Yep. Let's talk about the summer triangle.
Summer triangle is an asterism.
An asterism, which we learned about last month.
Yeah, so it's not a constellation, but it's a group of stars. This one is made up of Vega, Deneb, and Altair.
Okay.
Really interesting thing about those three stars are Vega and Altair are reasonably close to us in terms of light years. So they're 25 and 17 light years away.
Okay.
But Deneb is 2,600 light years away.
Oh.
So while it looks like they're, a triangle in the sky,
hanging out together,
Deneb is much brighter but much further away.
Oh.
Which we don't get that 3D effect really. When we look at the night sky, it's just like a black sheet of paper with holes in it, right?
Right.
But it's actually further out.
There's a lot of depth.
I loved one of the Artemis astronauts who said one of the things he loved about being up there was he could see everything in 3D as opposed to what we see, which is more 2D, right? So,
oh my goodness.
Yeah,
that
was
must
really
be incredible.
That was really a thrilling thing to hear.
Well, and all three of those are also part of different constellations, right? So we think of them maybe as one, but they all have their own other.
Yeah, this asterism connects Lyra, Cygnus, and Aquila.
Okay.
So particularly Cygnus is interesting because that's right where the Milky Way comes through.
Okay.
So if you find Cygnus, you see where the Milky Way is in the night sky.
Okay. And we'll be able to see it kind of straight up overhead?
Yeah.
As we head into the summer? Okay.
Yep.
Great. All right. We had some interesting fun facts too. Vega, let's see, 25 light years from Earth, 17 light years away. So that's that distance, right?
Yeah.
That we were just talking about?
Yeah.
Okay.
Yeah.
I love it. Okay.
Yep.
Incredible to see. Any other fun facts for this summer? I know we've talked about it last month, but of course, it's getting comfortable outside. So that's one of the nice things. But we have shorter nights, so that makes it harder
shorter
to view.
nights. But it's great to get out there. I recommend going someplace like, I go to Goldendale. Mm-hmm. It's a very dark sky area. They have a beautiful observatory there. It's worth it just to go see the observatory. And they do really nice shows there, night shows. They do a sun show down there. It is a state park, and it's just, I would say, go to Goldendale, find the night sky, go to the observatory. That's a great outing for the summer.
A great thing to do this summer. I'd love to see it. Thank you so much,
Thanks.
Keith. All right, still ahead. The Reuben telescope has been live for 1 year now, and it's redefining parts of space. We sit down with one of the women at the forefront of research and unpack the biggest discoveries from the last year. Stay with us. Welcome back to The Sky Above. I'm meteorologist Leah Pizzetti. 1 year ago, a historic telescope went live. The Reuben Observatory had big aspirations for unlocking untapped knowledge of space, and it has already blown scientists away in that first year. Joining me now to go through the highlights from the first year is Sarah Greenstreet. Thank you for being with me today.
Thank you for having me.
You are not only an affiliate professor of astronomy at the University of Washington, but an astronomer working for the Reuben Observatory at NSF NOAR Lab. I'm sure you are busy.
Very, yes.
Thank you so much for being with us again. You joined us last year when this first launched, but now let's take a step back and do a one-year recap, shall we?
Yeah, absolutely.
So let's talk about the basics. If anyone has not heard of Reuben, how would you define it?
Yeah, so the Reuben Observatory, as it's called, is a new large telescope that's located in South America. It's in Chile. It has the largest digital camera ever constructed. It's about the size of a small car. And it's going to use that to take images of the night sky. It's going to take about 1,000 images every single night, covering the entire visible sky every 3 days, and it's going to repeat that for 10 years. And in these images, it's going to find billions of stars, billions of galaxies, millions of objects in our solar system, looking for things that change brightness or move across the sky. And then all those images are going to be put together, and the Reuben Observatory is going to essentially construct the deepest time-lapse movie of the night sky that we've ever had. And so there's going to be a huge amount of information about the universe that we're going to gather. And even as we've been in the testing phase over the past year, we're still fine-tuning all of Reuben's many systems to get it working at its peak performance before we start that 10-year-long survey. Even as we've been doing that, we're already making incredible discoveries about really fascinating objects that are even already starting to hint that maybe some of our understanding about the solar system specifically might need a little bit of rethinking, which is pretty incredible.
That is wild to think about. I can't even imagine what it's going to be like in 10 years when we can review that. Oh my goodness. Okay,
Yeah.
and this has been decades in the making as well.
It has, yes.
It started with a literal napkin sketch in the 1990s.
It did.
The first formal proposal was submitted in 2003. Then through the early 2000s, all that building phase was happening. It finally went online in June of 2025. Happy birthday to Reuben.
Yes.
Let's talk about your involvement with the project. How are you involved directly?
Yeah, so I work on a team that helps get the astronomy community ready to do science with all of this data, as well as doing my own research as well. So one of the really exciting things is that with some of the first asteroid discoveries that came out of the Reuben Observatory last year, right after those were announced, my team of researchers at the University of Washington took those objects and started looking in them to try to see if we could understand how fast those asteroids are actually rotating, because that can tell us about potentially what the asteroids are made of. And that can then tell us more information about how asteroids are made and how the solar system formed and all that fundamental stuff that we want to learn about the solar system.
And you made a very significant discovery very early on.
We did, yes. We identified an asteroid that is now the fastest spinning large asteroid that's ever been discovered. So this asteroid is 700 meters, not kilometers long. It's about twice the length of the Empire State Building.
Wow.
And it spins one full time around in 1.9 minutes is all.
Wow.
And so it sounds like it might not be that fast, but for something that large, if you imagine yourself standing on this asteroid, you'd have to be holding on pretty tightly in order to still be able to stay on and not get flung off into space. So it's spinning a lot faster for this large type of asteroid than we have ever found before.
And what is the significance of understanding or discovering that this is a solid?
Right. So the fact that this is a large asteroid that's spinning so quickly means that it has to be made of something like solid rock. Traditionally, we've thought of asteroids as being something we call rubble piles, where we think of them as asteroids that are made of a whole bunch of different small rocks that are all stuck together, held together by gravity and cohesive forces. But something this big that's spinning so quickly has to be made of much stronger material like solid rock to keep it intact and not flying apart into many smaller pieces.
Wow. Oh my goodness. Okay. And we also discovered a large batch of asteroids.
Yes. Yeah. So Reuben has been steadily finding more and more of these asteroids over the past year. In February, they announced the discovery of 11,000 brand new asteroids that had never been seen before. Some of these are what we call near-Earth objects that are really close to the Earth. Nothing that's close enough to pose an impact hazard or anything like that, but they're closer than many asteroids, ranging all the way out into objects that are past the orbit of Neptune into the far outer reaches of the solar system. And 2 of those are on such extremely elongated, stretched out orbits that at their farthest points, they are 1,000 times farther away from the sun than the Earth is, which makes them among the 30 most distant objects in the solar system we've ever discovered.
Okay, and you kind of touched on this, but I want to go back to it. People hear asteroids and they think, are we doomed?
Right.
Will it hit Earth? We're confident it's not. That's not the issue here?
We have not found anything that is anywhere near the Earth that would pose any kind of hazard to the Earth. But that's one of the things that Reuben will be looking for, is to make sure that we can find as many asteroids as possible. We know where they are in the sky. We can calculate the orbits precisely enough that we know in the future where they're going to be, and we can then find anything that may possibly be on an impact trajectory so that we can know well in advance and try to do something about it if we need to.
Yeah, and this was all discovered this is the early part of this 1 year.
Yes.
Which is relatively quick compared to all other research done previously.
Right, yeah, so these 11,000 new asteroids that were just discovered earlier this year, that number is about half the number of asteroids that all of the telescopic surveys around the world discover in an entire year. And Reuben found that many in just a few weeks of looking at the night sky.
My goodness.
The amount of discovery that this telescope is going to be finding over the next 10 years is going to put us in a category unlike anything we've had before, with the amount of information we're going to have, not just about the solar system, but about the larger universe as well.
Oh my goodness, I can't even wrap my mind around that. And then one other discovery that we've made in the last year, objects in the far parts of the atmosphere out near Neptune.
Yes, yeah, these are the things that are out beyond the orbit of Neptune in the very far outer reaches, some of them being on these very, very highly elongated orbits that put them very far away from the Earth.
Which is cool because something that far away, we don't have a lot of eyes on.
Right, yeah. It's hard to see. Asteroids don't create their own light. We see them by the sunlight that they reflect off their surfaces. And so the farther away they are, the less light comes back for us to be able to see them. And so it's difficult to see the things that are really far away. We can really only see the biggest ones because those are big enough at their distance for us to be able to observe. So we've only found a few thousand asteroids out that far in the solar system, and Reuben just found 400 more. So it's also finding significant numbers compared to the discoveries that we already have in the solar system.
Wow, and we are only 1 year in. So one of the things that's special, like your specialty, as you mentioned, is how people can get involved in this research and jump on the bandwagon. Everything from receiving notifications when something is discovered to helping sort through different discoveries. Let's unpack all of that. We'll start with the notification system. There's a website people can go to and you can sign up for notifications.
Yeah, so the notifications, I think, are mostly for the astronomy community. I think there are ways for the general public to be able to hear about them as well. But there's so much data that's going to be coming out of this observatory, and already is, that trying to sift through all of those discoveries and be able to find the things that are most important to each individual astronomer, somebody who cares about exploding stars, supernovae, they can look for those objects, versus people who care about the solar system like I do, being able to just get the information that they want. There's ways to be able to filter all that information out. Because one of the really cool things about the Reuben Observatory is that it's going to be sending out alerts every time something is detected to have changed brightness in each image that it takes or that it's moved across the sky. So within 60 seconds of an image being taken, millions of detections of something that changed brightness or moved will be detected, and all of those alerts are going to go out to the world within 60 seconds of taking each image. So the first night that we turned on this alert system, we had 80,000 notifications that went out of things that were taken in just a couple hours of taking images of the night sky. And it's going to be millions every single night once we're actually running the real survey very soon.
Wow, okay. And there is a website that people can go to if they want to poke around and explore a little bit, right?
There is, yes. There, if you go to skyviewer.app. Some of the first images that were released last summer from the Reuben Observatory are available there. You can pan around, you can zoom. There's even sonification that's included in this as well, so that people who are visually impaired can experience the images through sonification, which is really cool as well. And it's a fantastic place. You just go to a web browser, type in orbitViewer.app for looking at the solar system objects, or skyviewer.app to be able to explore these images. And I've spent many hours looking at them, especially with my kids as well, which is really fun.
What a fun way to get your kids involved. Okay, we have a lot more to talk about, Sarah, but we're going to take a really quick break. We still want to talk about what's next with Reuben.
Yes.
I know this is just the first year, but we have a lot more to get to. So when we come back, what is next for the Reuben telescope? Welcome back, astronomer Sarah Greenstreet with me still. Let's jump back into our Reuben conversation. One of the best things is the citizen science element of it. Like you said, so much information is coming in, and we need your help.
We do, absolutely. So if you go to zooniverse.org/Reuben, you will be able to find some of our citizen science projects for the Reuben Observatory. These are a way for anyone and everyone to be able to help us sift through this huge amount of data to be able to help us make incredible discoveries with this telescope. So one of those is the Reuben Comet Catchers, where you can try to find brand new comets in the data. And they're great because you sign up as a user and they walk you through all of the steps. And you can potentially even end up on some scientific papers with some real astronomers in the end. So.
And it's family friendly too, right?
Absolutely, yeah.
I love it. Okay, so the first year, clearly a success. What is next as we move forward?
Yeah, so we've been working over the past year or so trying to fine-tune all of the many systems that Reuben has to get it working at its peak performance so that we are ready to start this 10-year-long survey, which is called the Legacy Survey of Space and Time, or LSST. And that 10-year survey is what we're going to use to create this incredible movie of the night sky, unlike anything we've had before. And we are going to be starting that. We don't have an exact start date yet, but we're hoping that it's going to be very soon in the near future, and we're going to get those 10 years underway.
So even though this first year has started and it's live, that 10-year window has not started yet.
Correct. Yes, even all these discoveries that we've made so far is still just in the testing phase as we're trying to get it working as well as we possibly can. So we expect even bigger, better things during this 10-year-long survey once we get it going.
This might feel as like a silly question, but I just need to know, a 10-year time lapse, how long will that play? Do we get it down to 30 seconds?
I'm sure there will be many different versions of it as well. Absolutely. It's a long time. It's a lot of information. So how fast it will have to get sped up to actually see everything flashing at you through the whole night sky will be quite incredible.
Maybe we're watching a movie there. Maybe it's 90 minutes.
Maybe bring the popcorn, yeah.
Okay, and then what about after that 10-year span? Are we there yet?
So things in astronomy take a long time. You talked about the timeline for how long it's taken us to just get to the point where Reuben is now taking data. It's been almost 20 years in the making from the first conception of this telescope. And so even with us not starting this 10-year survey yet, we are already starting to think about what is going to come next. We absolutely think that the telescope is going to keep running. Maybe we'll put new instruments on it that will let us see different wavelengths of light than we can see at the moment, and keep learning as much as we can about the universe for as long as we can with this incredible telescope.
Absolutely. Sarah Greenstreet, astronomer, thank you so much for your expertise. Can't wait to keep watching it. Well, that does it for us here on this July episode of our monthly astronomy show, The Sky Above. I'm your host, meteorologist Leah Pizzetti. We're back with you next month.